Okay then. So hi, Divjot, Ganesh here.
Hi.
So I've been working as a developer for the past 3.5 years. So I'm currently working with PayPal as a platform engineer. Yeah.
That's very nice. Very cool.
Yeah.
I don't really know many adjectives, so I'll keep on using cool and nice. I think Tejas. Uh,
Hi, Divjot. So we can start the session now. I think it's time.
all right. Sure. Awesome then. You have started the recording as well, right?
Yes, I did. I just started.
Good. Awesome. I have two screens, so I might be looking here and there, so please don't get confused. As Charlotte has already introduced me, I'm Divjot, and let me just share my screen as well. All right. And 1 second. Yeah, so you can see my screen, right?
Yes, it's visible.
Yes,
Awesome.
we can.
That's great. Now this should be very cool. Awesome then. So my name is Divjot, and I have, as Charlotte has already told, I have 6 years of experience as a front-end engineer, and I've worked with various companies, namely precisely four companies. And from that, I've learned several things. Some things I've learned by making a lot of mistakes. Some things I've learned by being around some smart people. And I just thought that, it would be a nice way for me to convey everything that I kind of learned from my own mistakes. And it would also be nice for you to know something from the industry, some vivid experiences of mine, right? So my name of the talk is Designs of a Coder. And as you have already guessed, I'm very bad at naming. And I think that's the first thing you have to do as a programmer, is that you have to be bad at naming. But we'll talk about it in some time. Another thing that I want to say is that I went through some of the code bases for this, I think, fashion app that you all had made. And I was very impressed. It was really cool. And a lot of good practices were used. And even the design was, I think one person even used Figma, one team, I think, used Figma for their design first and all this. I was very impressed. Like that alone is like some great high quality work. So first of all, round of applause for everyone who have contributed and all that. And it's really perfect. Cool. Applauses don't really work in Zoom, I think, so it's a bit awkward. Anyway, so let's start with the next slide. So before we begin about design, let's talk about what art is and what design is, because since childhood we have used this idea as interchangeable, right? We think art and design is really for creative people, and us mere engineers can only code. But there is a strong distinction between the two. So art is about personal expression. Okay, so anything can be artistic, right? Anything can be an artistic choice. And there's no good art or bad art. Even if I write very bad code, it is still artistic, right? Like it's my choice to write bad code. But if that code is to be used by someone, right? Or if that UI is to be used by someone, or if my software is to be used by someone, or anything really, even if a table is to be used by someone, it might be artistic if it is standalone, but if you start putting it in the context of its usage, that is where design comes in. And we definitely have bad design, right? You have probably encountered so many things in your life which you feel that, oh my God, this is so poorly designed. Oh my God, if they had just done this one thing, it could have been such a game changer. So this is where the distinction comes in, right? Bad movies, flop movies have their own followership, right? You might have seen so many movies that you know are bad, but because of their choices, they become artistic. But when that particular movie is supposed documentary for some particular purpose, then that is where the usage comes in, and then the design comes in. So this is one thing that I wanted to highlight. This meme from Parks and Recreation, one of my favorite shows. Here, Tom, this person is really fascinated by this modern art, and it's basically like, for me who cannot understand art, it's just squares and circles. and he's just fascinated by it, and he's like, this piece is giving me such an emotional reaction. Is that normal? So this is what art does to you, but that's not to be said for design. Speaking of the title of my talk, since it is a mandatory session, it doesn't matter what I name it because you anyway have to go through it. But if suppose it was a blog post, right, I would have to find the right titles for the SEO purpose, for getting more attention on social media, and I would have to then, find a systematic way to write that code. In this art, you wouldn't really say that there was a complex system involved with everything being symmetric. But here you have to do some sort of science, some sort of design thinking to get to the best title. And as per this arbitrary research that I've done, decoding design as a programmer would be a better title than designs of a coder. But this is my talk, so my title. So basically, to summarize, art is a self-contained, intrinsic piece, right? In itself, it is complete. You don't really have to judge it from the context. You don't have to judge it from where it was being done. Anything from decades old or even centuries old will be having some artistic value. But design is always externally validated, and it is always in the context of its usage. So I hope this distinction is gets you some perspective on how to identify good design, bad design, and how to identify, oh, this is just an artistic choice. So speaking of good design and bad design, since that exists, right? You can't say bad art exists, but bad design does exist. So let's see some examples of it, okay, so that we can understand it better. Apple, in my opinion, is known to be very good at design. Everything they make looks aesthetically pleasing, and it's also designed and fabricated in such a way that it gives you this unapologetic Apple, feeling, right? So they are known for having good design, and one could even say that since Apple have good designers, they should also have very good designed products. And at this point, I'm sure some of you people who probably don't like Apple or think that no, they have made such major design flaws would have already felt a contradiction, right? And then that contradiction is that no, even though they might have good designers, they have also sometimes made some design choices that are very bad. So this entire premise that I'm going through is basically to tell you that engineers can be very good at their technicalities, but it is still easy to make a bad design, even if you're surrounded by smart people. Without design thinking, without thinking about your customer, without thinking about your user, you can make poor choices. Take this for example. So I don't know if you are aware, but one on the left side is the MagSafe charger from Apple, and it's basically a charger, nothing fancy there. And similarly, the other one is a Apple Magic Mouse with its charger being plugged in. So I hope you can already see that one is trying to prevent a bad thing from happening. The MagSafe charger has this magnet around it, a very simple solution, just to put magnet around the charger, so that if you trip on it, it won't bring your laptop down also. It will just slightly, easily smoothly get unplugged. However, on the other side, okay, there's no magnet, so that's okay. But it is preventing you from using the mouse when it is being charged, and which is a very horrible design choice. So as you can see, like I'm sure both engineers who designed these, or both the teams that designed these two solutions, they knew how to make a charger. They know how to write code. They know how to create hardware. But it's the difference in the design philosophy they had. One person thought that, okay, we are anyway making a charger. What about we add this expensive solution of adding magnets, and that way we can make our customers even happy. They have a problem wherein they snatch the entire laptop whenever they move around, or their pet goes through the wire, and that can be prevented by just adding a magnet. So there you're saying that the engineer has, or the team has thought about a problem, they have thought about how can we solve it, they've thought of various solutions, and then they probably came to this solution. On the other hand, it seems like it's an afterthought that, okay, we have created this very pretty mouse, however, we don't really know how to charge it. Let's add a charging port at the end of the life cycle of the product design. And that is what it seems to me, it is like that. However, as I just said, both are charging the laptop. And this is where charging the device. And I hope this is where you can see the distinction between a good engineer and a great engineer. Good engineer will probably just do the job. You wanted something to charge this device, I will make that. And other engineer has probably thought that, okay, let me also enhance it further. So this is the difference between good and great engineer. I'm not going to say bad engineer, because the functionality, the ask was only that it should charge the device, right? Nobody ever knew that they need magnets in their charger, right? Before MagSafe, I don't think any other company or any large scale mainstream company had thought of adding this. So this shows you the difference between the two. And that is what we want to learn also, right? We want to become great engineers from good engineers. So that is pretty much what I'm trying to talk about in this talk. So continuing with the bad naming philosophy that I have imbibed, these are the three kind of designs that I perceive. One is that there's a design kind of design. Other is this hacker kind of design. And lastly, we have this other kind of design. Okay, so I know these are abstract, but it is mandatory talk, so it doesn't matter. So this slide I've actually just copied from one of the previous sessions that you might have gone through, which is of design thinking. So I'm sure you all you are probably familiar with this idea of what design thinking is and how it works. So I'm not going to elaborate much on it, but this talk is going to talk about several things around it. All right. Yeah. So let's start with the first category of design, which is design kind of design. And it's exactly what you think. It is the design of the UI, or design of some hardware, or design of the product, or design of some software. This is what I'm actually going to talk about. Since I'm not a designer, I'm not qualified to talk about it, but I am a user, right? And we all are customers, and we can identify what were the poor choices made in design and what were the good choices made. And that is what I want to reflect on. So first thing I want to talk about is paradox of choice. So basically, what I've understood is that users don't really like when you throw a lot of options to them, right? You give them all the options necessary to do their job. They get confused, or they feel that it is so complicated, I don't want to use it. And there's a resistance to use that. And when you decide things for them and decide the right things for them, even though they might not know what they really want, you can understand from their behavior what they really want, and you can make good decisions. And this is where I feel that good design and bad design comes in. This is not only limited to UI or even fashion stores, wherein they might decide which things are the best, which clothing line is the best for you, and they will only display it in the good light, and others are just tagged up around. So it's not only limited to such real life scenarios, it's also going to affect the software that we write. So I don't know, so you all have probably interacted with React, because all the code bases that I saw was all using React. And in React, you might have heard the engineers from the Facebook team saying that we really want our API surface level to be very low. We want it to be having low surface area, so that things are easy for users to use, and it is also easy for us to maintain. So earlier they had things like in the class-based components, they had things like component did mount, component will mount, component did update, and so many other lifecycle hooks. But in the recent update with using hooks, they have replaced all of that with this one elegant solution of use effect. And that's somewhat, deciding for the user that, okay, you don't really need such complicated options to do what you need. We will tell you how you can probably handle it. It can go both ways. Sometimes choice is what users really want, but it depends from case to case, and what is needed is design thinking to solve this. Let's take Apple's example once again. So in 2007, Steve Jobs had showcased Apple, the first iPhone, to the users. And in the same time, Palm had released this Windows Mobile. So they are from the same era. And it's not like, Apple had some access to future technology and they brought in. Both, if you compare, both have a touch screen, both have a way to take input, both are pretty much of the same dimensions and weight. Everything is pretty much, the technology was available to both of the engineering teams behind these, right? But in one, you are seeing that in the Windows Mobile, you can see that they know that users need to contact people, they need to calculate things, they need to email things. And because of that, they've just loaded the home screen as well as the keyboard with all the options that are necessary for completing that task, right? On the other hand, if you see iPhone, keyboard is only needed when you're typing. When you're not typing, you don't need keyboard, right? And similarly, you don't need to contact everyone every time you open the phone. And because of this philosophy, this change in philosophy, now we are using our phones for pretty much everything. Like if I wanted, this talk could have been on a phone, right? And that is only enabled by thinking in a different way, and innovation starts to come from that point. So I hope you can see that in the same era, in 2007, both engineering teams had access to similar technologies, yet they were able to come up with very drastic different devices, right? This iPhone from 2007 is not very different from a modern smartphone, right? They all do pretty much the same thing. Sure, our bezels are smaller, sure, our processors are faster, but the philosophy is pretty much the same. We are just iterating on it. So I hope this gives you some more context on how good design can be more maintainable and more scalable. Today, we don't see Windows Mobile anywhere, right? That it was at the peak of business smartphones, and now it's nowhere to be seen. So I hope this gives you some context. Next thing that I want to talk about is that not always technology is the answer to fix something which is just bad in design, right? As you could see in this slide, they're just adding a simple magnet to fix a problem. So it's not like they crafted some beautiful technology to fix it. It's just a magnet, which we know from, I think, some centuries now. But on the other hand, the design is so bad. No matter how many magnets I throw at it, it will always be bad. So sometimes you just need a simple design solution to fix a bad problem rather than using plethora of technology to fix it. And this I have an experience from using by working in Iran. And in last quarter, in October to December quarter, last quarter of last year, we had this problem that after the lockdown, we saw that a lot of our app ratings became quite erratic. We could see that sometimes we were getting very high ratings, sometimes it was going down, and we were unable to understand what is going on. And what we wanted was that, okay, we want our app rating to get better, right? And this is where the engineering teams were like, you know what, I saw some reviews of people saying that the app is a bit slow. So let us upgrade our dependency list. Let's use latest React Native. Let us use this new update of Redux or something, and let's make it fast, and then our rating will go up. Some said that, okay, our API payload sizes are quite huge, and we can just use GraphQL to fix it, and that our API payload will be small, and then our ratings will increase. Some said that, okay, I think our design is very outdated. We need to update our design. And you can see that how all of us engineers start to think about the problem from technology. We jump to the solution using technology without thinking that, okay, what actually is the problem, right? And one person, I think an intern, they even suggested that, let's just rate 5 on the App Store, and that way we'll get better rating. It might work for short term, but that's not solution to the problem, right? The problem was actually this, and just this graph is enough to understand what has happened. So if you can see, is my mouse visible in this slide?
Yes.
Yeah, okay, perfect. That's great. So as you can see, the teal color, the 1-star rating one, is pretty much the same throughout this duration. What has actually happened is that the positive reviews have gone down. So the problem is not that people are hating the app more. It's like people who like the app are not speaking up more. And this usually happens whenever you acquire a lot of users. So during the lockdown, a lot of people had to change their jobs. They had to switch to business. At times, they started having medical stores to have better job security compared to whatever job they were doing. And because of that, a lot of users were acquired just around the lockdown time. And those people, once they installed the app, they knew that, okay, this is great. It has been a life changer. And it has a lifesaver, and it has solved a lot of problems for us. And they started reviewing good. But then as time progressed, those people were absent. And that is why we got this spike in positive reviews. Otherwise, people who like apps, like the app, don't really talk about it much. This is the solution that we used, and then I'll talk about why we use this. So the solution is simple. Wherever the user reaches the order place screen, so something good has happened for them, they have placed an order, we give them this simple dialog. And if they click yes, we take them to the Play Store that please rate our app. And if they select no, we take the feedback right there. and we understand, okay, what exactly we need to fix. Is it the prices that you're not happy with? Is it the performance? Is it some design? Like at this point only, we can take the feedback and we know things early instead of waiting for it to go to Play Store. Then we pass the reviews with some ingestion engine, and then we understand, okay, what is that people are not liking. So this solution, as you can see, like it's something that you can probably make in a day, right? And the solutions that the engineers were coming up with, like GraphQL and React Native upgrade, those will take at least 2 to 3 weeks to get at least one API working, or at least the first version of the app running on the latest version, right? So as you can see that this simple solution changed everything for us. As you can see, since positive reviewers were going down, just by asking our customers that if you like the app, would you want to rate us? Only that, and they started doing that. Like they were happy, right? So they felt that, yeah, Udan has saved my life. Let me just rate something good on Facebook. As you can again see, the negative reviews have pretty much remained the same. So people who don't like the app or people have some problem with it, they are constantly being there. We have not changed that group at all. We have just ask people who like our app to rate us better. And you can see, even if the people like the app, that doesn't mean they will give 5 stars. They give sometimes 4 stars. So that has also increased, even 3 stars. So this was good insight for us. At the same time, we also got the people who are not liking the app. They gave us feedback right in the app instead of us going to the Play Store to then decipher from strings. Like sometimes they like app is useless, app bahut kharab hai. Like all those things are not really meaningful to us because we don't know what exactly went wrong for them. But when we give them a checkbox and ask them which things are bothering you, then we get better feedback, and then that helps us to fix something in the long run. So our goal for the quarter was that we have to increase our rating from beginning of the October. We were at some 3.1, I think, and our goal was to increase to something like 4.2 to go back to normal before lockdown or just after the lockdown. And that happened. Like it was such a simple fix, and you can see the change is like dramatic, right? That UI was made in one day, the implementation was done, and rollout was done in 3 days, and within weeks we could start a sharp increase in our app ratings. Another thing that you will observe is that earlier it was quite erratic, and this was happening because new users come in, some people give review, and then they forget. So this is the thing about I think about life, that whenever you're happy, you don't really think about it, that why you are happy, what has made you happy, right? You're just happy and you enjoy your life. But when you're sad, you find all the reasons that have made you upset, right? You find everyone who you can blame, that okay, because of this, my manager has caused this, my company has caused this, the government is going on. So when you're negative, at that point you find reasons why that has been provoked. But when you're happy, you don't find the reason to find the person who said something nice to you in the morning and you say, oh, thank you so much, it made my day. So we don't do that when we are happy, right? And this is something that we can probably reflect on. And just using that psyche only, we could, fix a big problem for us and got a lot of insight for the customers who are unhappy with our service. So this basically is entire elaborate part of the slide is basically to explain that sometimes simple solutions can fix a big problem rather than thinking of technology to fix everything, right? This another thing that I want to talk about in this first half is about perception is more important than the reality, right? We are all irrational beings. We try to be rational, but when testing times come or whenever something comes in our way, we start becoming irrational. And this is something that I observed in the code base that you all had shared. First of all, it was really nice, but something that I saw that it was it was making the experience slightly poor. So this is about loader design. So again, extending on the idea of simple solution to a big problem. So basically, whenever your app goes from one state to another, you have to give some transition because it won't happen in an instant, right? Things take some time. Our world is instantaneous, but our software is not. And because of that, because of the inherent latencies in the internet, in the processor, in the API or something or other, we will have such a need for loaders. And these are some three ways of popular ways of making a loader. One is of just showing a blank screen and then going to the next one. Other is to show a spinner or something like that. And last is to just craft a good designed skeleton screen, what it is called, a placeholder screen, to give experience of a smooth transition from one state to another. So these are three kinds of design for loader. And in this, you can see that as per this research, UX design research, they found that if the actual loading time is 1.5 seconds, the blank screen feels like to a user to be 2.15 seconds. So it's worse, right? The perception is worse than the reality. And when you add a spinner, it does help, but it makes it 1.9 seconds. And when you use something like a skeleton, it makes it 1.74 seconds. So if any one of you have ever worked on performance optimizations, you will understand that something from 2.15 seconds to 1.74 seconds is a huge difference, right? 400 milliseconds or 500 milliseconds, that's a big deal. And getting that is quite hard, right? Making sure the entire pipeline is first understood, each bottlenecks in the pipeline are resolved, and fixing that, it does take time. But here we are just playing with the design, right? We are just not even writing any optimized code. And that has just changed the perception. So this is something that I wanted to share, that sometimes, perception matters a lot instead of what the reality is. Cool. So this concludes the first half of the design part, the design kind of design. This slide was not supposed to be there, but now that I see it, I like it. If you have any questions or something at this point, you can leave it in the chat. We can take a 1 minute sort of mini break, and then let's go to the second half. Or you can also use the audio if you want. Anyway, we will have a Q&A session at the end also. So you can just jot down your questions otherwise. Okay, so I guess I'll move ahead, and in the end, we will come to all the Q&A. You can keep on using the chat. I am looking at it, so feel free to use that. Okay. Now let's come to the hacker kind of design. So this is where basically I'll be talking more about the code, right? The code that we write, how can it be designed better? So I'm not going to tell you how to write fast code or performant code. I'm going to talk about how to write the code which is designed in a way which is more maintainable, more easy to understand, easy to read. So that is the kind of design that I'm going to talk about. First thing that I want to talk is that all the C++ school exams that we have gone through, or all the teachers who gave us those tricky infix, prefix, postfix sort of questions about C++ or even whatever language you were taught in school, those have somewhat made us think that complex code is what is to be written. Complex code is cool. Any person who reads complex code is smart, and any person writing complex code is also thus smart. And this is not true in industry. This is only true in academics. It is true probably in quizzes, but not really in reality. In reality, you write code for humans. You are not to write code which is so complex that even humans need to take time to read it. Compiler will write such complex code for the machine. So let compiler do all that complex stuff, and let humans write code which is as close to English or whatever language we want to follow, and as readable as possible. And once you write readable code, it actually unlocks a lot of other things. This is another meme from Office, another series that I really like. So here, this girl Kelly is complaining that this person Daryl, is very complicated man. And the thing is that he says exactly what he's thinking. Like, what kind of game is that? So her problem is that he's being too direct, and he's being too simple and too obvious. And that is something which she's not able to understand, because she's a dramatic girl in the series. So she likes a lot of drama, and this is just confusing her so much. And I felt like this when I went from college to Office. I started seeing that, okay, like we were taught all this complicated nonsense. And when we go to our companies, we see such simple code, very elaborate verbose names, which are easy to read, easy to maintain. Why are we doing this? What sort of game is this? So I hope you might also relate to this. This is an example for the code that I'm going to talk about. So I'm sure you all are smart enough to understand what is happening here, right? Basically, we are trying to make a function which takes A and G. A seems to be like age, G seems to be like gender, And based on that, we are telling what title should be used. Should it be Miss, Master, or Miss or MR, right? So it's a simple function, but just by using such complex constructs from the language, we are making it hard to read, and there's no need for it. You may write it like this, and it will make it slightly more easy to understand that, okay, if age is less than 18, then we do this, otherwise we do this. But again, this has some of the problems here also, right? We are doing a lot of nesting, we are doing a lot of returns, that a lot of else statements that are not really needed. So you could actually rewrite it in another way and make it slightly better, right? You can do that. Okay, if you can remove else's and just rely on exit or from the return, right? So this is another thing that you can do to this. But these are all, I think, temporary fixes to the problem. The problem is not that the construct of the language, suppose the ternary operator of, or the way if else is written, or the way return itself works, that is being too complicated. I don't think that's the problem over here. The problem over here is that the logic, like age is less than 18 or gender equals to female or male. I think there's a bug over here. No, there's no bug. Sorry, I don't write buggy code. So the problem is not that the if else return statement are hard to read. It's that the logic age less than 18 or gender equals to female or male, that is being mixed with the data that we want to represent. The data like Miss, Master, Miss, and MR, those are being coupled with the logic itself. And that is where we are saying that there's no separation of concern. I propose this solution to the same problem, right? So here what I've done is that I've created this title map, and this map has all the data that I need to know. So reading this data, I can understand minor people are called this, adults are called this, right? So that is understandable. And in the function that I'm doing, I'm only dealing with logic now. I'm not dealing with the data, right? And here I've decoupled the logic from the data. So tomorrow, when I have, suppose transgenders start to have another title for them, it is easy for me to add that logic over here, right? I don't have to add another if statement, another else statement and fix it. I can just change my title map and it just works, right? Or for minors or for children, we find another title. For that, I just need to change the logic over here and add the new data. I don't have to complicate this function further and further. So point being that boring code is actually much more readable, but getting there is a bit hard. So this is having no indentation, right? These are two on the first line, and this is data. This could be from API or anything. So this has actually reduced the complexity of the code. At the same time, it is also quite easy to maintain. So that is the first point that I want to talk about, is that the colleges and schools have taught us that complex code is what we should write, but actually using your data structures like objects and arrays in the right way can enable a lot of possibilities, right? It can make it easy to maintain or even performant. You can optimize something looking at it, right? Next thing that I want to talk about is Unix philosophy. And this is a big topic. Like, I think one can make multiple talks just about Unix philosophy. And I felt that it is needed to be said if I'm going to talk about anything around code design. So here, like, look at this code. I took it from Wikipedia. So it says that Unix philosophy originated with Ken Thompson's early meditation on how to design a small but capable operating system with a clean service interface. If you just replace operating system with product and clean service interface with easy to use, something like that, you can see that it's basically, again, going back to the idea that we want to write something, we want to design good products that are easy to maintain or easy to use, right? And that is what Ken Thompson understood from his undertaking of writing an operating system. So these are the 4 points that Unix philosophy are about. I'll just go through them briefly. So the first point is about that each program should do only one thing. Let's not complicate a function by keep on adding more and more arguments to it. Let's just make distributed sort of functions. Each function does one job and they do that job very well. And anyone who has used Mac or Linux or Unix, they would know that this works really well in CLI. You can pipe output of grep into ls, into then cat, into then echo or something or else, right? So that is what Unix philosophy is about. That makes small programs that do their job well. The second point is again related to the interoperability of each project of each program. So one program should be able to work with another. So here, the point that don't clutter output with extraneous information is basically about the CLI particularly, that if your output is always text stream, then each text can be understood better, right? And it can be piped from one to another. So adding unnecessarily complicated output will make it hard to pass. So, but it's also true in our APIs. If you have a consistent data structure, if you have a consistent scheme for using your objects, it will become easy to integrate two different programs or two different functions or two different APIs for that matter. This is where I feel a lot of good things come from. So third point is that design and build software, even operating systems, to be tried early, ideally within weeks. Don't hesitate to throw away the clumsy parts and rebuild them. This is what I feel a lot of us struggle at once we join a company and start working on a big project, because we think that the solution to a problem is something like this, that to create a cool program or to create a cool API, you take first few months to fix how, first few weeks to write the right code, use all the best practices, do all of those things. And after 1 month or 2 months, you show the entire project like it's done. So this mistake of going into this silo and working without telling anyone what you're working on, and at the end showing this, having this master stroke of your program, is what causes this problem. And here the suggestion is to not do that. Suggestion is to instead do something like this. You keep on iterating over your project, and you keep on taking feedback. And that way you will make your project quite more maintainable, and you will not go into this trap of bad decisions, right? If Apple engineers had made the prototype of mouse to be used by some of their colleagues, they would have quickly pointed out that, okay, charging is very hard, so please don't do that, right? And they could have fixed it early. But because that doesn't go through a long process, I'm not sure what happened at Apple. But my point is that this does happen in a lot of companies. So in this example, what is happening is that to draw an owl, you create two circles and ask, does it look like an owl? And they'll say, no, owls are birds. Birds should have wings, so add wings. Oh, where are the feet? Oh, where are the ears? Where's the beak? Where's this triangle thing? Where are the eyes? Where it looks quite smudgy. Can you add some boldness to it? Can you also add some color now? And that way you make a project which is, iterated through so many iterations, and that way you achieve something which is appealing to the customers, right? You're taking early feedback. So this is what the third point to me makes sense, is how it makes sense, right? So another thing that it talks about is that don't hesitate to throw away the clumsy part. This is one mistake that I made at my previous company, wherein that I got in this project, which was very cool. We thought we'll solve all the world problems using that project. And I got so attached to it, it became like my baby. And I got so attached that I was not willing to leave imperfections in it. I wanted it to be perfect. And because of that, I kept on building it without taking any feedback. And at the end, when I left the company, that project is now dead. So this is a mistake that we make, wherein that we get too attached to our software and then we continue iterating without any feedback. So third point really resonates well with me. Another point is that take time to not do manual job, but to automate some of the things. Okay, so it says that use tools in preference to unskilled help, right? And that way, what will happen is that suppose you have this fashion app that you were making, right? And in this app, you want to go to the state wherein that you add one item, then a mini cart opens, and in that promo is applied. You want to reach this state. So while testing, what you will do is that, okay, I'll click manually add, then I'll open the add to cart panel, and in that I'll try to apply this coupon. And that way you're doing this unskilled sort of work wherein you're just clicking things to test. If instead you made a simple component in React, which would accept Redux state object, and it will just replicate that in the UI. That way you can just dump this state that, okay, open panel with one item with this promo applied. And with one click, you can actually open that panel again and again. And in that process, you have not only made your development life easy and also for your colleagues, you've also probably understood your product better. That, okay, each time I want to open the panel, I can't just refresh my page. I can't just refresh my tab. I have to actually click and then open that panel. If I just embed this part of the state that open this mini cart, in this URL itself, then I can just refresh and it will come and it will be good experience. So these things you only learn by being lazy, by questioning that should I really do this manual labor? Should I find another solution? Should I make a tool for this? And that is where again Unix philosophy helps. And that is how you create the first thing, that you make a lot of programs doing one thing well instead of making one program doing so many things. And that is what pretty much the 4 points of philosophy are. And they have been iterated again and again, changed multiple times. But I felt that it is needed to be said. And this will probably help you to design your software in a better way. And this is coming from a person who has designed the operating system, right? Unix. And that's not a small job, right? So I do believe a lot of things over here are quite relevant even to something like front-end development. So yeah, we just went through this. This is again something I picked from the code bases that I had seen. And it is about making impossible states impossible. And you'll probably scoff at this idea that what do you mean? Like, obviously impossible states are impossible. That is why they're called impossible states. Or how will a user ever reach to an impossible state? Our program will ensure they will never reach there, right? But trust me, as stupid as our code is, similarly, our users can also reach undesirable places in our app. So do think that this is a possibility. And this code I picked pretty much from the code bases that I saw for that fashion app. And it's not that someone wrote this. I picked some of the ideas that were used over here. So I saw that you were using some Redux store, and in that we were using Booleans, right? So is loading, is authenticated, is admin, is error. Such Booleans were being used. And the problem over here, I think it looks neat, right? There's no indentation, too much nesting. Everything looks quite easy to read, maintainable. If I want to remove dashboard, I just delete these 3 lines and it's done. So all that is true, but there's still a problem. It does work, okay, it does work, but there is a problem. So the problem is that suppose while the app is loading, an error occurred. Now, right now, what will happen is that because error occurred, and so is loading and is error both will be true, is loading will be called first, and because of that, the user will be stuck at the loading screen forever, even though the error has occurred, right? Ideally, what should happen is that either error should take more precedence, or nothing like this should happen, that loading and error both are true. So impossible state can be possible by buggy code. So that is one thing, that your user has no idea what has happened. They're just seeing the spinner going again and again and again, even though there's an actual error over here. And this does happen with multiple companies. It's not something which is only freshers or you juniors struggle with. Even experienced developers end up with writing some sort of buggy code. Another problem that could be over here is that suppose there's some logic in authenticated functionality. So is authenticated is coming out incorrectly whenever the user is admin, and then they are seeing something else, right? In that case, they will see login page, and even though they are admin, they are stuck to the login page or something or other like that. So I'm not going to go too much into details of how the permutation and combination of these booleans can mess up the app, but I hope you get the point. My solution to this is that you use something like a enum, right? So now what we are doing is that instead of having multiple booleans for multiple states, we have one state with multiple values in it. So either it could be loading, or it could be error, or it could be normal user, or it could be admin. So now again, the surface area has reduced. If there is a bug, it is only in the user status. I don't have to see combinations of multiple booleans. And if suppose I have to add another state to any of these things, suppose I want to show a normal user a different error. So normal user error can be added to user status, and then that can be rendered differently. And I don't have to worry about any of other states because I've just created a specialized enum value for that. So this is one thing that I saw in the code that you all can benefit from, that using a lot of booleans, while they may work, they also make the code a bit hard to understand. You have to do a lot of and all. But using an enum and then using those values can give you a better experience. This concludes my coding part of things. Okay, so now we'll talk about the last part, which is the other kind of design. Please feel free to add anything on chat. I will go through it during the Q&A session. Okay. Yeah, so now we'll talk about other kind of design. So basically what I want to talk about here is not the design, product design, not the code design, but rather your career design, how you can probably design your career to ensure you get maximum out of it, right? And since I'm quite early in my experience, I don't know a lot of things. I do know some things from my experiences though. So I'll just narrate those. Okay. So one is this thing called imposter syndrome. So have you ever thought like this, like, oh, Sharma ji ki beti ko itna kuch aata and I don't even know anything, and she's younger than me and she knows more than me, right? Or if you open Twitter, you see everyone making side projects every day, and you feel that, oh my God, these people are so smart. I don't make enough. I don't do enough, right? Or even in suppose this chat, you might feel that if I ask this question, I might come out as a stupid person, or they might judge me that I don't even know this, and that might reflect poorly. So this self doubt comes in, right? And sometimes you even whenever you join a very good company, I'm sure you all are already in good companies, and you will join better companies also. At that point, you might think that, oh my God, everyone here is very smart, and I don't even think I'm worthy of coming to this company, and I don't know how they've hired me. Maybe I'm a fraud. Maybe I've just been too lucky, and that is how I've come here. So all these things basically are symptoms of imposter syndrome, in which you feel like you are an imposter, a fraud, and you don't deserve to be here. You actually deserve to be at a lower position. And this is basically a self-induced harm to ourselves, right? We are just unnecessarily making our life difficult by thinking that, oh, we are not worthy of whatever we are getting. And it is also sort of coming from the society, I feel. The society induces so much of self-doubt that they keep on comparing you with someone else, and you start imbibing it and thinking that, oh, actually, the only way I can live my life is to compare with the neighbor. And that again creates this problem. So, and this is a really bad thing, right? If you don't ask the questions, you will never learn, right? If you pretend to be smart, that if I don't ask this question, I will look smart. And because of that, you will not learn, right? But reality is obviously not like that. What you might think that you know this green circle, but actually and other people know everything else, but that's not true. What actually happens is that you know a subset of things, they know a subset of things, there's some intersection, and there's some negative space also. So that is the reality. But because of our way our mind makes us feel and makes us doubt ourselves so much, we feel this bad feeling that we don't know enough, or we don't deserve to be here, and that's really bad for your career and for you in general. A stupid person has so much to learn, but a person pretending to be smart prevents themselves from learning. And this is something that I learned, I think, in the third year of my career, that all the smart people that I saw never feared asking questions, even though they were stupid as anything. They asked those questions. They were like, okay, I don't know what this is. Please explain to me. And I'm like, you are 12 years senior to me. You should probably be knowing, right? I am now inducing self-doubt in them. But that's not the case. They are there because they keep on asking, they keep on learning. And that is how they ensure that growth happens. And if you start pretending to be smart, that is where you don't grow. Now you're just turning your eyes, blocking your eyes from learning new things, and that's just self-induced harm. So that is first thing that I want to talk about. That imposter syndrome is a real thing, and it's very much there in tech industry, and even more in Indian culture. I think that because of the self-induced doubt, a lot of problems come from that. Another thing is, which you might have faced already by joining some new company, is that not invented here syndrome. By the way, these are real syndromes. Okay, although my naming is very bad, these are actually, academically named things. So not invented here syndrome is a syndrome in which the person thinks that a better thing would be which we have created ourselves, and not something which someone else created for us. And this comes specifically to the junior engineers or someone who has recently joined the company, wherein they feel that the previous code is so bad, it is so old, it is reusing some old library, I should rewrite it. I should write it in this library now. Or I don't want to work on bug fixes. I want to work on features, new features. I want to work on greenfield projects. I don't want to work on old things. I don't want to work with legacy. And this is again stopping you from learning new things, right? You're not exposing yourself to new things that you can learn from old mistakes, right? I think history is a great way to learn what you should do next, right? But instead of saying, oh, I don't want to go through that, I want to make something new, I want to make my own mistakes, a very valid point. but we can also help from learning from the mistakes done in past, right? So this is what not invented here syndrome is. And you will always have this, like even I have this for my own code. Like I might write this code 6 months ago and now I feel, oh, this is too old, I need to rewrite it. It is working perfectly fine, but still I feel like, no, it's not using latest technology, I have to rewrite it. And that is something we all have to resist, I feel, because the goal is not to write code which is to be kept in a museum, right? The goal is to write code which is to be used. No matter how clunky it is ultimately solving a problem, not to be looked at, oh my God, look at this code, so perfect. Like that's not what they're trying to do over here. So this is what not invented here syndrome is. And this is what I like. I found this photo to be very interesting. If everybody starts reinventing the wheel, we are not collaborating anymore. Sometimes there is merit in doing something, innovative, but that doesn't mean that every time you see something legacy, you think, oh my God, this is old, I need to upgrade. Oh my God, this is bad, I need to use a new library to fix it. So that will lead us nowhere. We'll keep on being in this fatigue of destroying old things for new things, and then when they become old, we again make new things. So I thought this photo is quite interesting that way, that everybody is making a wheel when they could have started making a car with 4 wheels. Uh, some of the solutions for these syndromes that I've already discussed while talking about the syndrome, and you might have also just intuitively figured that, yeah, if I have the syndrome, this is what I should do. But some of the solutions that I think are applicable is that, first of all, acknowledging that you're not alone. Everybody that you see has somewhere or other made this mistake of feeling that, oh, they're not smart enough, or feeling that I need to rewrite this code. I need to constantly refactor the code, only then it is good. So this mistake everybody makes, and it's okay. First of all, accept that this is happening. And the people that you think are so smart and all, they have made these mistakes and they've learned, or they might be just faking. They might be pretending to be smart, and you're just buying that. And again, that just makes it worse. Another thing that I feel is that every engineer can benefit from is trying to communicate more. This is basically coming from the Unix philosophy only, right? To iterate so much and to keep on releasing it every week or something like that. So by discussing your solution before you're going to implement, maybe writing an RFC, request for comments. This is quite popular in open source. So before writing anything, you first tell that this is my design and this is what I want, and can you just comment on it? And before doing that, then while you're making things, you can keep on updating your status, right? You can keep on sharing what you've achieved so far, like that owl example, and you can take feedback. Oh, actually, this is more important than that, and you can course correct. And also after the implementation, once you have implemented something, you can still measure a lot of things on real data. You can still validate those things and keep on iterating. And that is one thing that I feel over communication. I just don't mean that you spam each Slack channel telling everything about what you want, but rather communicating at the right moment about the things that are relevant to your work. So that is another solution that I think of. One more thing is to resist coding. So this is quite counterintuitive. I'm basically suggesting that don't jump to code. Think about it, take some time, absorb the problem. That is when creativity will come, right? You might have encountered this problem wherein that you are fixing this bug, it is taking so much time, and you slept because you couldn't fix it, and in the morning you suddenly know how to fix it. So give your body time to be creative, to think of the problem from different perspectives. If you just jump to coding, you have just thought of one perspective that, okay, the problem is probably here, let me fix it. And in that, you might be fixing symptoms, not the root cause. So my suggestion is that take your time to code. Don't jump to refactor anything. Don't jump to think that, oh, this is very bad, I need to change everything. Take your time to absorb everything that is happening and let your mind be creative. Every mind is creative. It will have the creative juices. Just give it some time and it will come out naturally. Lastly, I would say that be detached to your code. Your code is not for museum. Your code is next person's legacy code, right? The person joining after you will say, oh, this is legacy, let me refactor. So being attached to something which is so transient, so temporal is pointless, right? It will go away. You will change the job. That code is no more yours. It is of the company as per the job letter, offer letter, right? So don't be attached to your code so much. Just think that that code serves the purpose of solving a problem. And from that, you can also learn new things instead of feeling that this is my code, I have to make it perfect, I have to do this and that. There is a place for perfection, but perfectionism can also cause a lot of problems. So these are some fixes that I feel can be done to make your career a bit better, and to design your career in a way in which you're more receptive to learning new things. So this is what I thought of the last phase of my talk, about designing your career in order to learn more things instead of just doing the same things again and again, right? That's pretty much it. I have taken 53 minutes. I think that's quite a lot. And thanks a lot. Thanks a lot for being here. And now we can have the Q&A session. And one thing that I do want to say is that my talk is only to broaden your horizon, right? I'm here to tell you what you might not know, what you might not know, how to be a better candidate against your other counterparts, right? How to land jobs where just being better at code is not enough. You also have to be creative. You also have to show this ability that you can think above the code level, right? And that is the distinction between a good engineer and a great engineer. And that is what my talk was all about. As you can see, the mask shows something, the reality of our current affairs, and so does my expression. I shouldn't laugh. It is quite sad, and we are probably going through the worst time right now. And it's, even if your family might not be affected by it, just the knowledge that something is happening outside is very scary, and it is enough to make our mental health quite bad. So I do want to take some time talking about it, and just that we all know what is the right thing to do. We know how we can protect ourselves. We can just do the responsible things and try to stay as scientific in this problem as we can. As I said in the talk before also, we are irrational people, and during testing times, our irrationality comes out. But that is where we know scientific method works. We know how to prevent problems, but it's hard for us to follow that. And that is why we are here, right? If everybody knew that, if everybody just followed the right protocols, we could have prevented so many things, and it's still not late. So I just hope we all try to be as scientific in this approach in solving this as possible. So that's pretty much it. Sorry for ending on a sad note, but it is the reality, and it is probably someone's reality, some of our neighbors' reality right now. So that is what I wanted to end with. Thanks a lot. We can start with the Q&A session. Okay. Amanjot has asked, is it good design to club two technologies like PHP and React in a single code? It's a good question. So I feel you can take inspiration from other things and realize what is actually good or not, right? The separation of concern, which is the idea that two different concerning things should not be tied together, right? Like your data and your logic, your business logic and your data source, they should not be tied together. That is separation of concern. But that doesn't necessarily mean that separation of technology should also be there, right? In React only, you can see that React basically lives on this idea of JSX, which is merging HTML into React. And then we also have something called CSS and JS, right? So I don't think the clear answer is that you should never mix technologies or you should always mix technologies. I think it depends on situation to situation, very diplomatic answer. But regarding this specifically about PHP and React, we can for sure say that merging Node and React is a good idea, because Node can then enable server-side rendering, right? And that way you can have a faster app or better optimized SEO app. Regarding PHP, you need to check, you need to iterate, you need to find what benefit are you going to get by merging it, and what are you trying to solve using it. If the answer to both are I don't know or I have to check, then that probably means that it's good for research work, but not really for solving any problem as of now. So that is my answer to PHP and React in a single code base.
Okay.
Does that answer, does it help you?
Yes.
Yeah, cool. One more thing that I can add over here is that if your concern is about maintaining code bases, so suppose you are a team of 3 engineers and you all work on this PHP code base and this React code base, and you feel that maintaining 2 repos, going through issues for 2 different repos, going through PRs of 2 different repos, sometimes whenever you change PHP code, React code has also to be changed. And that is, if that is your concern, you can look into something like mono repo, in which you have different projects in one repo, so that whenever one thing is changed, and if suppose you have changed the API in PHP and then React code also has to be changed, that can be co-located. So if that is a problem of code maintenance, then sure, you can have two different projects in one repo called mono repo, and that way you can probably solve that particular problem. Okay.
Okay.
Yeah.
So if we have, like React for front end, and we are also using PHP for front end, and we are prior to moving, our PHP code to React side, should, I make a different repo for React, or should I do it within a single repo that I want?
Yeah, it's a good problem, and I'm sure everybody goes through this some time or another, wherein you want to move from old technology to new, and how to transition in a smart way is basically the problem over here, right? And for that, I would say you do your own research. That is a better way to find out the answer, what your engineers are comfortable with, and what other teams might have done in past. That you can definitely research. I can see it happening quite well within the same code base, in which that you probably just replace each xyz.php file with xyz.jsx file, and then use Webpack in a smart way to combine all of that into a bundle. So it can be done in both ways. Now you have to see who is comfortable in your team, who all are comfortable with writing custom Webpack plugins or spending time with Webpack, or if they just want that, see, this code is old, we will definitely get rid of PHP. We will just take 2 months off, do everything in 2 months, and then do it. So it definitely depends on the team. I am not really the right stakeholder in this, but both ways will definitely work as per my experience.
Okay.
Yeah.
Hi,
Yeah.
hi Divjot. Like, you have any question? What?
I think this question by Mohammed.
Yeah, please go ahead. I'll just wait.
Yeah. Yeah. So there's a question that what should we prefer, a good feature or a faster, smoother app? Good question. And I hope like I illustrated the idea that the point of our code is not to just write features for the sake of features. The point is to solve a problem, right? Coding is a solution to a problem, not in itself a thing, right? So if your users are concerned about performance, first of all, measure that. Are they concerned, right? Like we did this negative feedback to understand what are people concerned by, see what people would really want and what is actually driving your conversions up or down. And based on that, make an informed decision. And you can change it, right? It's not like either or. You can make a good feature this quarter, but next quarter you can improve performance, or you can do half of both things in one quarter. So it's not like you have to always pick one off versus another. So that is my basically answer. That these questions don't have one trademark answer. It has to be tested. You have to measure right things. You open up Google Analytics. If you are using Mixpanel or Sentry or whatever, look into it and see when people are dropping off. If suppose you're seeing that one person goes from one screen to another, and because the loading time is so much, they dropped off. The conversion from one screen to another is so low, that means that something bad is happening in this transition. Either the screen looks bad, or the page loads quite slowly, or the page just doesn't load only. So, or your measurement is also incorrect. That also happens, right? You are measuring the wrong thing. So do that. If the conversions look good enough that each person is going from one page to another roughly based on their interest only, then that's good. Performance is probably good. And about a new feature you don't know. If the user is not knowing what new feature you're going to make, they can't say what they want, right? So for that, you will have to do user research. You will have to do study. I'm using these heavy terms, but that doesn't mean you have to do some complicated research. You have to ask. Probably your dog fooding is one example, right? You can ask in a survey in your own company, what will you like? Will you like this feature to be added, or would you like this particular page to be sped up? And if people say, oh, this page is very bad, I refresh the page and it takes 10 seconds to load, and I'd want it to be fixed right away. And some people say, oh, this feature actually, you know what, I think it could be better that way, this way. So that means the idea is still not clear in that feature. So based on that, do your own research, try to find the right solution. And from that, you can choose one or another each quarter, each week, each time, each sprint, whatever the quantum you use for time. each sprint you can find the right thing to work on. Does that help, Mohammed? You can use chat if you want.
Yeah,
Yeah.
thanks.
Okay, cool. Awesome. If you don't agree with me, please let me know also. I will try to give more perspective or even admit that, okay, I said something wrong. That's okay. All right. I think Shankara, Ganesh, you were having some.
Yeah, basically, right. Whatever the design aspects of points that we have discussed till now are pretty much uh, like applicable for startups, right? When you're working with when in your case you work with Samsung and Swiggy, etc., right? So you have worked with a startup kind of environment, and you have worked with like a pretty huge organization which has its own terms of designing and like designing
Yeah.
teams and all. So there would obviously be trade-offs while working for such big organizations. Like how do you keep your design aspects alive when you're working for such big companies?
Um, Very good question. And I think as you jump from a corporate to a startup to back to a corporate, you will also observe these things, and these are quite valid. And first of all, it depends on the culture, right? A big company can have good culture, which can allow you to be more vocal about what you want to do, and that is where discussions can happen. See, I don't know if you have seen this. I'm sure you can Google this. That there was a study done that teams that have more conflicting ideas or who contradict a lot, they come up with better solutions compared to teams who are more harmonious. So that is where the culture aspect comes to it. That is one thing that I want to say, that if a company doesn't have a culture where people can be vocal, it's very hard for one person to change this huge organism that is a company. So that is one thing that I want to say. Second thing is that I don't necessarily agree that big companies don't do design well or small companies always do design well. Each company has its own flaws. Each project has its own flaw. One team can do things better than other team. All companies, even in Swiggy, you can see that there's a concept of food ordering, right? Which is since 2015, 16, right? And there's also the idea of Instamart, which is something very new. So in the same company, you can have two different kinds of team, right? One team working on a tried, tested formula, one team trying to do something radical. So these things will keep on happening, right? And in same company, you can have both sort of cultures. So one team will be more open to new design ideas, radical solutions, and trying out things. Other company would want to other project might want to keep things in the same way and try to iteratively, very calculatively change things. So that is another point that I want to highlight, is that even in startups, you can have bad design. So many startups that fail usually are because of not doing enough market study, not doing user study, right? So that can also happen. And even big companies who fail, as I like, I'll just go back to my slides, okay, and just look at this. Yeah, look at this, right? Apple was a big company, right? And they had no need to they were making iPods at this point. They were a big company, but yet they thought it's better to design something very, extraordinary. Palm was a very tried, tested sort of solution, right? They knew what works. Business customers want clunky things. They want very complicated things, and this product will do that. So Palm was an established company. Apple never made a smartphone before this, right? The only time they made smartphone was when they made iPhone. And Palm was making smartphones, or Windows Mobile was a tried and tested solution for making smartphones since a long time at that point. Yet we can see very different results. A big company doing something which old companies couldn't do, right? So hence, I would slightly disagree that it's not always true big companies can't do good design and that always startups will have good design. It depends from place to place. I personally, as one engineer, what you can do is that whenever you choose a company, do your research, ask the employees whenever they are taking your interview rounds, what is exactly the culture like? You can ask exactly such questions. That has there ever been a scenario wherein an engineer suggested a design solution which is now live, or something like that has ever happened or not? And if they say, oh, that never happens, we have a dedicated design team, they only do it, then you can see that, okay, that company is much more fixated and they are not having a lot of collaborative or open-minded discussions on how they should make their product. So first thing that you can do is find the right company, right culture. And second thing is that if you are in that company, you can start being vocal You can say, why don't we do this? Why don't we do this? Right? It is because of that imposter syndrome that you might, silence yourself. That no, I don't want to speak up. No. Jaisa chal raha hai, chalne do. The way things are going, let it be. And because of that reason, you might not open up a lot. So that is the second thing that I want to say, that if you are in such company which is not quite open, start opening up, start giving your ideas, start giving feedback openly, even if that means that you might not be seen in a bright light. That's okay. You are just doing right thing for the company, right? You're just vocalizing more. So 3 solutions, not that big companies, small companies. I don't fully agree with that distinction. Sometimes big companies have good design and small companies have poor design. And second thing is that if try to choose the right culture, right company, so that you are in a company where such collaborations can happen or such innovation can happen. And if you are in such a company, you can always be vocal, you can always give suggestions, you can always talk to your manager, their manager, CEO, co-founder, you can always talk and try to just make the product, that company better for everybody. So these are 3 solutions that I can think of right now.
Like I was not thinking like big companies don't have good designs. I mean, the amount of say an engineer or a developer would have in different companies. That's what I was trying to portray.
Yeah. I'm sorry for long answers and I don't take necessary feedback in between, but I understand what you're saying. But again, it depends on the culture, right? So, like at Udan, engineers can do that. Like Udan is made with the idea of having very flat culture wherein engineers take product calls, product engineers take software calls. That happens. So that also is true. And I was also in a company like Samsung, a big corporate, where feedback wouldn't be rolling out quite easily. It is a big corporation. It will take time for drastic changes to happen. So it depends from company to company. And all you can do is just try it out, be vocal, see if it works. If it works, great. If it doesn't work, there are a lot of other companies also. So yeah.
Great.
Hi, Divjot.
Yeah. Hi.
So we talked a lot about collaboration, or like how we can collaborate, and truly software engineering is basically this aspect that you need to collaborate a lot. But coming from a startup culture, I want to ask this. So this question is more into leadership. How we can actually instill this culture of collaboration. I understand that there are phenomena like peer review, code reviews, etc. But I want to know from your experience, like you've been to quite a lot of companies. So what basically you saw, how they instill this culture of collaboration?
Very valid question, and something that even I'm trying to figure out in my own company. Because of the lockdown and the way we are all quarantining, it is hard to even humanize, socialize. That collaboration becomes a bigger problem, right? We aren't even able to talk to our colleagues in a non-work environment. And because of that, I feel even socializing is very hard. So this is something I'm also struggling with. And for that, I've discussed with some of the people in my own company, and we thought that, see, the problem is that you have no problems in collaborating with your friends or people you feel comfortable with, right? If you want to do something together, you just call and that's done. But when it comes to colleagues, it becomes a bit difficult for whatever reason, right? And I think that finding those reasons and then tackling one after another is one approach that you can take. Wherein that if they say that I want to collaborate, but I'm so busy with my work, I can't do this, then in your whatever journal feedback the company takes or your HR, you can just say that if they just have 10 to 20% extra time somehow, or they reduce other things, then we can have this collaborative session also. Or you can just start making, start socializing more with your friend, with your colleague. And in that, you both will have, we'll bounce off new ideas, and that way you'll have, that way you can collaborate while socializing also. So these are some things that I am working on in my company right now to increase collaboration, but it is a big problem, definitely. And I'm also willing to know more about how we can do that. So yeah, these are the things I can say.
Sure. One follow-up question, and this one is going to be a little bit mean. So we talked about collaboration, but we also need to maintain the individuality sometimes. Like, of course, everyone wants to shine and climb up the ladder. So how we can balance both of the same things, like maintain individuality and also do the collaboration part?
Yeah, good, very good questions. However, like I feel I'm not really an HR person, and these questions are better answered by people, even like Rahul Yemni, like who have actually made a company, created teams. They know more. I've only been part of teams. I've not made any teams, so I'm not really qualified to answer. All I can say is that talk to your HRs, try to collaborate with them to figure out how we can solve this, and they might have much more better ideas because of their qualifications. That is what I can say. But this is something that it is hard, because do realize that a company is a group of people and an individual is just an individual. They might not be able to change everything from their capabilities while also working on other things. So I think more qualified people might be able to answer this better.
Sure, thanks.
Uh, any other question? Um, Feel free to ask. If you are feeling a bit shy, you can use chat. And if you still are feeling shy, you can follow me on Twitter or just send a message on Twitter. This is my handle. And there also you can personally connect. And if you want, that can also be arranged. There's also this feedback form in the chat. You may all please fill it, and that will also be highly appreciated. All right. I'll wait for 1 more minute if there's any other question, and then if there's none, you can all say that you have no more questions. That can also be done.
Hi, Divjot. Just wanted to ask a very specific question since you are engineer regarding testing in your code base. There are many tests like unit testing, are there snapshots, are there end-to-end integration.
Yeah.
Some companies they include everything in it. Some skip the unit test and just test the end-to-end testing. So what do you think out of all these is must have in a code base?
Very good question. And I have also been part of various companies in which there are some mandates that you have to have this much coverage, or you have to do this testing. This testing you should ignore. So several companies have their own opinions on it, and several teams, engineering teams, also have their own opinion. Like a greenfield project might think that testing can be done later, and a old project might start introducing testing to improve stability. So all these things are definitely opinionated. I personally feel that any test that helps you do your things, your development better, is what should be done. So if you're right now working on this complex feature, and you made one change and a lot of bugs came out of that change, that means that you could probably benefit from having a test around that complex piece, which actually works, not for the sake of testing, not for the sake of coverage, but something that, when you push the commit, you see a cross from Jenkins or Circles here, whatever continuous integration you use, you see a cross and you know that something broke for sure. And those sort of tests I feel are the most beneficial, because testing is only for developers, and for them to understand how to write more stable code. Other forms of testing are also needed for ensuring stability for customer point of view. But as developer, you will only benefit from tests that actually make your life easy, that make you feel confident that your code is tested by your series of tests, and it will definitely work. So that is my personal opinion.
Okay.
Does that help?
Yes, yes.
Great. Anyone else?
So is there any other question for the speaker? If not, then
I guess no.
okay. I think we have another question. All right. So
All right.
yes, Divjot. So thank you so much for this beautiful session. I think it was very interesting and incredibly useful for all of us.
Thank you so much for your kind words.
Now, before leaving the session, I would request all of you to please fill the survey form, because it is very important for us also to collect your feedback and to understand how you have liked the session so far. Okay.
Definitely. So are we done?
Yes,
Thanks for the
Divjot,
session,
we are
Divjot.
done. Thank you so much.
Yeah.
Guys,
Thanks all.
please take 5 minutes to fill in the feedback form. Give me your honest feedback. And once you're done with your inputs, you can leave the session. Thank you. Stay safe and have a great weekend.
Thanks all. Take care. Bye.
Thank you.
Thank you.
Thank you.